Sketch the graph of the following function, x plus 4 over x squared minus 5x minus 36. Before I find vertical asymptotes, because I see part A is asking us to determine all asymptotes, I'm going to try to simplify because I feel like maybe the denominator, we can factor it and cancel something out. If the denominator has a factor of x plus 4 so that I can cancel it out, this graph has a hole. So let's see if we can factor this, okay? So the numerator is x minus 4, x plus 4. I'll keep it the same. But the denominator, let's see if it factors. Two numbers that multiplies to be 36. I'm thinking 4 and 9. See, I'm trying to see if I can match this top and cancel it out. What if I have x plus 4 and x minus 9? Will that give me this trinomial? 4 times negative 9 is negative 36. Yes. And if I do 4 minus 9, that is negative 5. So look, oh, interesting. This factor of x plus 4, let me cross it out with the dotted line, it cancels out. Okay, so f of x does not have two vertical asymptotes. It's simplified to 1 over x minus 9. So it only has one vertical asymptote. Vertical asymptote is at x equals positive 9. Because 9 is the number that will make the denominator 0. It also has a hole. I'm going to mention that, okay? It has a hole at the x value of what got canceled out? The x plus 4 got canceled out, right? So we have a hole at x equals negative 4. The x coordinate will be negative 4. But what will be the y coordinate if I plug in negative 4 into this function? I will get 1 over, because I'm trying to find the y value here, 1 over negative 4 minus 9, which is 1 over negative 13. So we have a hole at negative 1 over 13. And if you want to know if we are doing an okay job, if we're doing, we're getting it right so far, I can bring up a graphing calculator real quick and try that with you, okay? So take a look. I'm gonna go to Desmos graphing and then type in the original function, f of x equals x plus 4 divided by x squared minus 5x minus 36. So I suspect that there is a hole at, I have a typo, sorry, let's change that to 5. We have a hole at negative 4, negative 1 over 13. And I do think there is a vertical asymptote at x equals negative positive 9. So let's see, I'm going to zoom out and show you more graph. Okay, so I think we got the vertical asymptote right. You see that green dotted line? The graph is decreasing infinitely to negative infinity, and the graph is increasing to positive infinity. So we have that vertical asymptote right now. Let's think about that vertical, the hole at 4, and they converted into a decimal for me, but I want to zoom in to this point. I'm going to click on this graph and just be on this graph and try to achieve approach negative 4 and see what happens. When I am at negative 4, it says undefined. So we definitely have that open circle you see, we have a hole at negative 4. And on the y value, I think we got it right. I think the graph definitely goes through that point. So far so good. Okay, so you can always for your homework problem, you can graph it to see if the parts of the graph that we are finding by hand are correct. Now let's find the horizontal asymptote. I'll write that down over here. Now, the easier way, I guess, is using those cases that we learned in pre-calculus that when you're comparing the degree of the numerator and the denominator, notice the biggest exponent on top of the fraction is 1. The biggest exponent in the bottom of the fraction is 2, right? The bottom is bigger, right? So this is a case we have a horizontal asymptote at y equals 0, okay? So if you just memorize these cases, when the bottom number is bigger, if the horizontal asymptote is automatically at y equals 0, that's okay, but why is that true? And we can actually do the work, okay, show the work by finding the limit as x approaches either positive infinity or negative infinity. So we can do that real quick in this video, but we know the horizontal asymptote is going to be at y equals 0 because the denominator's degree is bigger, okay? But why, okay? Now what I can do is I can write down the limit as x approaches positive infinity of the function x plus 4 over x squared minus 5x minus 36, okay? And this is a review from chapter 1, really. Okay, if you want to find the limit as x approaches infinity, we're going to divide all terms by the x raised to the biggest power in the denominator. So look, the biggest exponent in the denominator is x squared, right? 2. So I'm going to divide all these terms by x squared. So the numerator, which used to be x plus 4, is now x divided by x squared plus 4 divided by x squared. In the denominator, we used to have x squared minus 5x minus 36, right? All of these are also getting divided by x squared. Okay, now the next step is to simplify this. Limit as x approaches infinity. All right, let's simplify one thing at a time. All right, that's going to turn into 1 over x. Now next, let me move this. 4 divided by x squared. It doesn't really simplify, it's just that. Now let's go to the bottom. What about this? X squared divided by x squared is 1. All right, next term, this one, minus, I put the plus sign, but let me get rid of this plus sign and do minus 5 over x. And then lastly, this one, minus 36 over x squared. Now, anytime you have a number on top of the fraction, and x or x squared or x cubed, like x in the denominator, those will turn into 0. So take a look and see what happens. This will turn into 0. This will turn into 0. This will turn into 0. And this will turn into 0. Anytime you have a number on top, dividing by x or x raised to a certain power, think about, you know, as the x gets infinitely big, we're dividing 1 by an infinitely big number. We're dividing 4 by an infinitely big number squared. So when you divide something, a number, by, like, you know, very big number, that turns into 0. So that's why this entire fraction will now turn into 0 plus 0 on top of the fraction, right? And in the denominator, we will have 1 minus, what? 0 minus 0. So if you simplify this, this turns into 0 over 1, which is 0. So this is the work behind why the graph has a horizontal asymptote at y equals 0, because we can see as x approaches positive infinity to the right extreme of this graph, the function is approaching y equals 0. But this is the work behind these cases that we just memorized back in pre-calculus. And if you see our graph, I can go ahead and sketch y equals 0 and a dotted line. Let me see. If you follow the right end of the graph, you see the red line is coming down. You see how it is approaching that purple dotted line. So we do see this graph has a horizontal asymptote at y equals 0. Okay. All right. And that was a limit work to support that. Now that's been 10 minutes already. Now, you know what? So part A was kind of big. I think I'm going to stop this and show you the intercept and the next couple steps in other videos, okay?